Okay, hi. So part of the assignment today, and today is the 16th of April, part of the assignment today was to fill out a Google form and tell me if you had any questions. It turned out that some of you did. So I am going to go through those questions now that were asked about. Some of you said you didn't have any questions, and that's fine. And if you're still watching this video, even though you said you didn't have questions, I think that's awesome. All right, so one question that was asked goes back to problem set 4.1, and this is question 4. And I'll just read it to remind you since it's been a few days. A batter who had failed to get a hit 7 consecutive times at bat, then hits a game-winning home run. Very exciting. When talking to reporters afterward, he says he was very confident that last time at bat because he knew he was due for a hit. Comment on his reasoning. I think this is very poor reasoning. If this batter is someone who has sort of like a typical batting average in MLB, it'd be like a batting average like 0.2. I guess you said don't say it with the point, right? You say the batting average is like 250. You read it as a decimal if you're a math person like me. Okay, so a batting average of 250 means, if you think of it like a percent, which is what it is actually, it's like 25%. And so let's say that this batter gets a hit 25% of the at-bats. Okay, well that means that over time, maybe there's times that his batting average goes up a little, goes down a little, but it's not going to change because of what has happened previously. If anything, his previous poor experience would suggest to me that maybe he's not a very good batter, right? And so it's not due for a hit, okay? This is someone believing in streaks. Streaks happen, okay? So we can't think that just because there's some kind of a streak that implies something about the future. It does not. Okay, streaks can just occur. And so we shouldn't read too much into that. We should believe in the averages that exist for this situation. And if this batter's average is getting a hit 25% of that bats, we should think that that's about what will happen. He's just a little on the low side. That doesn't mean he's necessarily due. Okay. All right, the next question that was asked about is also from problem set 4.1, and it is problem number 5. That is a true picture of my old van. Oh my gosh, so sad. We were in an accident a couple years ago. And just like anything in my life, I think, how does this relate to stats? Well, it made me think about this question. So insurance companies collect annual payments from drivers in exchange for paying for the cost of accidents. So you or your parents right now pay a certain amount every month to cover you as a driver. And that amount, if you add up all of the payments over the course of the year, is not going to be as much as the insurance company would have to pay you if you got in an accident. So you might think, well, how do insurance companies make money? Well, it's because most people don't have accidents, fortunately. They pay their little amount each month, and then that money's just gone, right? They don't get anything back except the peace of mind knowing that if they did have a bad accident like we did with our van, it would be covered. So part A says, why should you be reluctant to accept a $1,500 payment from your neighbor to cover his or her accident expenses? Well, if this is your only client, that $1,500 is not going to be enough to cover the cost of their very nice $50,000 car if they were in an accident and totaled it, okay? So that $1,500 is a big risk if they are your only client. Now, if you're actually an insurance company, that's okay because an insurance company is going to get $1,500 for every person. Okay, so however many clients they have, you multiply that by 1,500 and they get a big sum of money. And then most people are not going to need any of that money. Most people are going to need $0 from that big pool of money. And so even if the insurance company has to pay out for a few accidents, they're still covered. Okay, so this is the same thing that the casino does, right? The casino is going to take money, little bits of money from everybody, and then have to pay out a big sum of money every now and then, but most people aren't going to get any money back. It's the same exact thing. All right, the next question that was asked about was from problem set 4.2, and it's problem number 1. So to remind you of the question, suppose you live in a city that has 125,000 households that actually still have landlines, and a polling agency decides to select 1,000 of them to call for a survey. What is the probability that a particular household, such as yours maybe if you still have a landline, would be selected? Well, this is just pulling on our definition of what probability is. Probability is the number of successful out of the number of possible. So there are 1,000 possibilities and then 125,000 options, and all of these zeros would cancel all of those zeros. So I would just be left with 1 over 125. If I reduce that, then it said to write it as a decimal and as a percent. So we would need to find those two numbers. So as a decimal, if you do 1 divided by 125, you get 0.008. And then remember that when you switch a decimal to a percent, you move the decimal place 2 places, the decimal point 2 places. So if I scooch that over 2, I end up with 0.8%. So that is less than 1%. Okay, sometimes people get confused when there's a decimal point and a percentage, like they write 80% or 8%. So just be cautious, it's always the same rule. All right, and then it says if a probability is written as a decimal, it will be between, has to be between 0 and 1 if I write a decimal. But if I write a percent, then my probability has to be between 0% and 100%. 0 as a percent is still 0, but 1 as a decimal, again, we're moving that decimal point 2 places like I just mentioned, and that would be 100. The decimal point moving here still is 0, right? 0 with more zeros is still 0. Right. Another question that was asked about was problem set 4.3, number 1. And Paul and Jay decide to have lunch together, and then they decide to flip a coin for who pays for lunch, and then they flip a coin for who's leaving the tip. And so first they said list the elements of the sample space. Well, it could be Paul pays for both. It could be Paul pays for lunch, but Jay does the tip. It could be Jay pays for lunch, but Paul pays the tip. Or it could be Jay pays for lunch and Jay pays the tip. So those are the only possibilities, okay? Are these equally likely? They are, because it's a coin flip. So the probability here that Paul pays is a half. The probability that Paul pays the tip is also a half. And since I said and, I'm going to be multiplying here. So 1/2 times 1/2 is 1/4. And each of these 4 outcomes would have a probability of 1/4 for the same reason. It has to do with leaving, it has to do with it being based on a coin flip. Okay, so write that down. I'm not going to write that down. All right, part C says, what is the probability Jay will have to pay for lunch and leave the tip? Well, that's just this one outcome out of the 4. All right, another question that was asked about was this one where we're talking about dice. And so there's going to be 2 dice. One die is red, one die is green, and we have to decide if these are disjoint. So remember, disjoint is when in the Venn diagram, you have 2 sets that are completely separate with no overlap. So either the 2 events are going to be disjoint, or there's going to be overlap. And if there's overlap, that means that there is some way that both events could happen simultaneously. So the first one said, okay, I roll my 2 dice, one's red, one's green. The red comes up a 3. The red also comes up a 6. That's not how dice work. Dice come up one number, okay? So I can't have the red die be both a 3 and a 6. That would be the side with a 3 facing up and the side with a 6 facing up. That can't both happen. So this is this kind of picture. There's no way that both of those can happen at the same time. So this is disjoint. The red die is a 3, the green die is a 6. Can those both happen at the same time? Yes, they can, right? The red die could show 3, the green die could show 6. That's completely possible. So this is not disjoint because they both could happen at the same time. This one says the red and the green add up to 4, at the same time that the red die is a 3. So could I have the red die be a 3 and have the red and the green add up to 4? Well, sure, if the green die was what? A 1. Is that possible? Can you roll a 1? Absolutely, that's possible. So 1 plus 3 definitely adds up to 4, and the red die is a 3. Those can both happen at the same time. So they have something in common. Both of them could happen, so that's not disjoint. The fourth option, the red die and the green die add up to 4. The red die shows 4. So if the red die is a 4, what would the green die have to be? Well, they have to add up to 4. Well, then that would have to be 0. Can I have a roll of 0? No, that's not how dice look. Dice have the numbers 1 through 6, okay? The typical die. So this can't both happen. If it is impossible for them both to happen, they have to be like happening separately from each other, then we have events that are disjoint. Right? A way that I could express this would be to say, can this happen? Red and green add up to 4? Sure. Can the red die be a 4? Sure. But they can't happen together, right? They would have to happen at separate times. They have to be separate groups. They have to be separate events. That's disjoint. All right, and then another question that was asked about was 4.3, number 9. This is a tough one. So for a promotion, I don't know if you paid attention to this before, but almost all the questions in stats class, by the way, come from some story in my life. And there was one summer my husband and I were collecting these off of soda bottles. So for a promotion, there are winning code prizes, like winning, like you open up the screw top of the bottle of soda and you open it up, and then underneath there's like a code inside. So there are winning prize codes in the caps of 7% of all Coke products. You buy 6 bottles. What is the likelihood that you win something? Now that word matters. It doesn't say that you win once or twice or 3 times or 4 times or 5 times or 6 times. Any of those would be fine. Some winning is what we're looking for. So notice I just said 1 time or 2 times or 3 times or 4 times or 5 times or 6 times. I don't want to have to figure out each of those 6 probabilities. What did I not say? Winning 0 times, right? So if I were to want to know the probability that I win some, I'm going to say, well, that's the opposite of winning no times. Okay, and winning not at all, we sometimes call that losing. Right? If I don't have any winning bottle caps, then every one of my 6 bottle caps was a losing code, right? It has a little message that says, oh, try again, play another time. Okay, thank you very much. Okay, so let's think about the 6 bottles that we have. Okay, let's see if I can draw bottles. Answer, I can't. Okay, this is like, they don't even look like bottles to me, and I'm the one drawing, and they look like salt shakers. Okay, well, whatever. Okay, so it's just to help you visualize. All right, so if this first bottle slash salt shaker, I'm just kidding. If this first bottle, I look at it, I have a 7% chance of winning. What is the percent chance that I lose with this bottle? That'd be 93%. It's the opposite of 7%. So there's the probability that that bottle is a losing bottle is 93%. I want the probability of losing every time. So this has a probability of 93% of being a losing bottle, and this one has a probability of 93%, and so does this one, and so does this one, and so does this one, and so does this one. Notice I said and. So I'm going to take 0.93 multiplied by itself for every one of those bottles. Okay, and then the short way to put that into your calculator is 1 minus 0.93 to the 6th. Okay, you work that out and you get, okay, whatever that turns out to be. Thank you for listening to this video. I hope you found it helpful. I am so appreciative of the fact that you guys are working and trying to learn right now. I know that we are in hard circumstances and that every day you have to kind of give yourself a talk and make yourself have enough energy to do your work. And I really, really appreciate that you do. Thank you.